Today we are going to discuss about arithmetic instruction. Last class we are discussed about the instruction set, the set collection of instructions. So one of the instruction is type of instruction is arithmetic instruction. Arithmetic instruction means it containing addition operation, subtraction, increment, decrement, multiply and division instruction. So all these instructions are 8-bit. So important one for 8051, the arithmetic addition, subtraction, increment, decrement, multiply and division instructions are 8-bit. And there is a 16-bit DPTR increment without the affecting the flags. So there is only a increment in instruction which containing a 16-bit DPTR, data pointer. Then different types of arithmetic instruction. We know that addition, subtraction, increment, decrement instruction. Additions add, subtract, increment and decrement instruction. These uses different addressing modes such as register, immediate, direct and indirect. So these are the different addressing modes for add, subtract, increment and decrement. Then there are two set of addition instructions are there. One is add without carry, that is one type, and second type is add with carry. So here there is no carry and here with carry. So if there is a content in A, then A plus B is done, but in there is no carry. If add with carry means it added the carry flag content. If carry flag content is C, so that will be also added with this registers. And it also has 4 addressing modes. And another one is subtraction instruction. There is only one set of subtraction instruction, that is subtract with borrow. Subtract with borrow. So subtract without borrow can be done in 2 steps. So there is only instruction, subtract instruction is containing only one subtract instruction, that is subtract with borrow. So if we want to do a subtract without borrow, then we are first perform clear the carry. So clear the carry means carry flag will be set to 1. So subtract operation, again perform the subtraction operation. Then subtraction operation means accumulator content minus here SSB B. Subtract content B from content A minus carry flag. If carry flag is 0 means there is no effect of the carry. So actual here without carry a subtraction is done. So next one is C, OV and AC. These are the flag. C means carry flag, OV means overflow flag, and AC means auxiliary carry flag. Auxiliary carry flag. So when carry flag will be set after an addition operation, the result will be greater than FFH. So the maximum value, it is an 8-bit. So 8-bit data operation is performed, addition operation is here. So 8-bit largest value which is that FF. So if the data is answer is greater than FF, then carry flag will be set. Then another case, if the subtraction, when a subtraction operation performs, then result is less than 0, 0. So that is a negative value. So it then after the subtraction, the result of the answer is less than 0, 0. Then again carry flag will be set. Then next one is auxiliary carry. When auxiliary carry flag will be set, after an addition or a subtraction operation, the lower nibble, that is if 1, 0, 0, 1, 0 0 0 1 0, then 1 0 0 0 0 0 0 0. So when we add this number 1 0 0, this is the one part of the nibble. So this adding this 1 1 plus adding this 1 1 plus 1, we know that 0, there is a carry. So from this nibble, lower bit of nibble, there will be a carry to the upper nibble. So we will add this 1 to here. So this causes to set the auxiliary flag. So during the addition or a subtraction operation, there is a value from lower nibble to upper nibble. Lower nibble means lower 4-bit value. So from that there is a carry from lower bit nibble to upper nibble, then auxiliary carry flag will be set. Then this auxiliary carry flag is also used for decimal adjustment used by the instruction DAA. DAA is decimal adjustment accumulator. So next one is overflow flag. It is useful in addition and subtraction of signed numbers. That is very important. Is mainly used for signed numbers. When overflow occurs during the addition and a subtraction operation, then overflow flag will be set. Then next one is multiplication and division instruction. Here we are using only register addressing mode. So for multiplication and division, we are only using register addressing modes and use only A and B. So what are the registers used for multiplication and division? A and B register. So overflow flag is affected and useful in determining whether 8-bit multiplied by 8-bit result in an 8-bit or 16-bit number. So നമ്മൾ രണ്ടും 8-bit മൾട്ടിപ്ലൈ ചെയ്യുമ്പോൾ 16-bit ആണോ റിസൾട്ട് അതോ 8-bit തന്നെയാണോ റിസൾട്ട് എന്ന് ഐഡൻറ്റിഫൈ ചെയ്യാൻ വേണ്ടി വി ആർ യൂസിങ് ഓവർഫ്ലോ ഫ്ലാഗ്. ആൻഡ് ഓവർഫ്ലോ ഫ്ലാഗ് ഈസ് ഓൾസോ യൂസ്ഫുൾ ഇൻ ഡിറ്റർമിങ് ദ ഡിനോമിനേറ്റർ വാസ് 0 ഏർലിയർ ഓർ നോട്ട് ഡ്യൂറിങ് ദി ഡിവിഷൻ. സോ നമുക്ക് ഡിവിഷൻ്റെ ടൈമിൽ ഓവർഫ്ലോ ഫ്ലാഗിൻ്റെ യൂസ് ചെയ്ത് നമുക്ക് ഡിനോമിനേറ്റർ 0 ആണോ എന്ന് ചെക്ക് ചെയ്യാൻ പറ്റും. ഇപ്പോൾ ഓവർഫ്ലോ ഫ്ലാഗ് ഈസ് ഇക്വൽ ടു 1 ആണെങ്കിൽ അതിൻ്റെ അർത്ഥം ഡിനോമിനേറ്റർ 0 ആണ്, അല്ലെങ്കിൽ ഓവർഫ്ലോ ഫ്ലാഗ് 0 ആയിരിക്കും. അതുപോലെ തന്നെ ഇവിടെ 16-bit ആണെങ്കിൽ ഓവർഫ്ലോ ഫ്ലാഗ് ഈസ് കണ്ടന്റ് വിൽ ബി 1, അതർവൈസ് 8-bit ആണ് റിസൾട്ട് എങ്കിൽ ഓവർഫ്ലോ ഫ്ലാഗ് കണ്ടന്റ് വിൽ ബി 0. Then next addition operation is DAA. Arithmetic instruction is DAA, decimal adjust accumulator, is used only register addressing mode and only uses a accumulator. An increment DPTR instruction has only one addressing mode, that is 16-bit register addressing mode, and we are using DPTR. DPTR is a 16-bit register, so it has either DPL or DPH, data pointer lower order byte or higher order byte, each has 8-bit. And these are the arithmetic instruction: add, add C, add without carry, add with carry, subtract with borrow, increment, decrement, multiplication and division. In multiplication and division we are using only two operand, that is A and B. Then add instruction. Add A comma Rn. Rn is a register. It starts from R1 to R7. So add the content in the register with accumulator and result will be stored in accumulator. For example, add A comma R3. So R3 content, here it is R3 content is 01, accumulator content is 03. Then after executing this instruction, the result will be stored in the accumulator will be adding these two content 0 plus 1 01 plus 3, that is 04. So accumulator content is modified to 04. Then add A direct. Here address of the data will be directly specified here, then that content will be added with the accumulator. So add the byte at the direct address into A. So here for example, add A comma, instead of R3 we are specifying 85H. Here we are specifying add A comma 90H. 90H represents some port, so that port address containing 90H is a port that containing data 3 and accumulator containing 1. So this content, this address pointed by this location containing the data 03, that will be added with 01. So the accumulator content will be changed to 04. So here add A comma R1. So here move into the byte from the address pointed by RID. So here this address register containing the address and that memory location content will be stored added with the accumulator, and result will be stored in the accumulator. And all these flags are affected: carry flag, auxiliary carry flag, and overflow flags are affected. Add A comma hash data. Here immediate data will be added with the accumulator. For example, add A comma hash 01H. So accumulator content is, suppose it is 04, then 04 is added with 01, then its accumulator content is changed to 05. Then add C accumulator A comma Rn. Here example is, if the carry flag containing, add C means add with carry. So if C containing 1 and A containing 01 and register R4, suppose R4, add C, this is the instruction, add C A comma R4. So R4 containing 03, what will be the result? We are adding these three content, then it will be 05. So accumulator store 05. If accumulator value is 0, then what will be the result? It is 04. So add C accumulator direct means here the byte at this direct addresses is added with the accumulator and result, and also added with carry. So add C indicate carry, and add C A comma Ri, it indicates add the C bit, that is carry bit, then and the byte from the address pointed by the RC and plus accumulator, and result will be stored in the accumulator. Next add C A. Here the accumulator content is added with C and the immediate data specified. So it is C plus accumulator content plus immediate data. So and result will be stored in the accumulator. The next one is subtraction, division or multiplication instruction. Subtraction instruction SBBBARN. Here Rn indicate the any register from R1 to R7. Then here subtract with borrow. So subtract the borrow at accumulator minus Rn minus C, and result will be stored in accumulator. This operation will be take place. Then here SBB A comma direct means the byte at the direct address, and C borrow carry flag or borrow at the C bit also subtracted from accumulator. So instead of here it indicate the byte at the direct address. And next one SBBARI. Here subtract the borrow at C bit and byte from the address pointed by the RID. So here it indicate the RI indicate the address where which, for example, this instruction will be written as example is SBBB A comma at the rate R1. So here at the rate R1 containing 90. So this 90 containing address 90 containing the data 03. So accumulator containing 05 and borrow containing 1. Then what will be the result operation? A minus this 03 minus 01. So A minus means A content is 05. 05 minus 03 minus 01. That will be 01. So accumulator containing 01. So this operation will be take place using this instruction. So RI indicate the address. So we are taken the data from that given address and that is subtracted from the accumulator. Then SBB A hash data, here it performs accumulator minus hash data minus carry flag content. And next one, mul AB is an important instruction. Here multiply A and B. So only there is an instruction mul for multiplication in 8051 mul AB. Then result will be stored in A. The next one is div AB, division. So divided A and B and remainder will be in B and quotient will be A. So if we divide div A comma B, if A and B are 05 comma 04, then if we divided div A comma AB, then A containing 5 and B containing 2, then A divided by B will be take place, that is 05 divided by 2. Then if we divided, then quotient will be 2 and remainder will be 1. So this quotient will be stored in A, the quotient will be stored in A and remainder will be stored in B. So remember this one. And for an MSB multiplication, for the case of a multiplication, the MSB will be stored in B and LSB will be stored in A. And decimal, next one is the decimal adjust accumulator using BCD number. So after addition, then we are using a DAA for decimal adjustment. That is, last class we are discussed about if it is greater than 9, we will add it with 6. Next operation, increment decrement operation. Increments means data content is incremented by 1. So increment A is equal to A value is incremented by 1. Here increment register. So INC R1 indicate R1 content will be incremented by 1 and that will be stored, result will be stored in R1. So increment direct means the address byte specified in this direct address will be incremented by 1. That is, if we specify INC 90H, so 90H content is 5, then 5 will be incremented by 1 and its value will be 6. Then same increment A comma RI, the increment the byte at the direct address RI. And increment DPTR containing a 16-bit data bit that will be incremented by 1. Then next instruction, decrement. Decrement A means accumulator content is decremented by 1 and result will be stored in accumulator. Same here, register content decrement Rn means register content will be decremented by 1 and that result will be stored in Rn. And here direct means the byte in that direct address will be decremented by 1. And this all about uh, arithmetic instructions.